Hi, so in this video, I'm going to be going over right triangle trigonometry. This is something you should have covered last year in Algebra 2, and you briefly touched on it in geometry. In geometry, you've previously talked about sine, cosine, and tangent. These make use of a right triangle with a hypotenuse, which is always your longest side, and it's always across from the right angle. And then you have two things that are called legs. These are, or in geometry, they're called legs, and then in higher math, they get called opposite and adjacent sides. Opposite the angle I care about. Remember, yesterday or 2 days ago, we talked about angle notation, and that this symbol right here means theta, and it represents an unknown angle. So in this problem, theta is the angle I care about, unless otherwise stated. And then this side up and down right here is opposite that theta. And then right here, this is my side adjacent to the theta because it is literally part of this angle right here. So the 6 trigonometric functions are sine, cosine, and tangent. And then their reciprocal functions, which are cosecant, secant, and cotangent. And then off to the side, I have written each of their abbreviations that will be used when you are writing out the functions and solving math, and additionally when you're typing them in the calculator. So sine is abbreviated SIN, cosine is abbreviated COS, tangent is abbreviated TAN, cosecant is CSC, secant is SEC, and cotangent is COT. So then I have my relationships. Sine is always the opposite side of the angle over the hypotenuse. Cosine is always the adjacent side over the hypotenuse. Tangent is always the opposite over the adjacent. Sorry. Cosecant is always the hypotenuse over the opposite. Secant is always the hypotenuse over the adjacent, and cotangent is the adjacent over the opposite. Notice that when I look at these trigonometric functions, these two are opposite ratios. So sine and cosecant are opposite each other. I've just flipped the hypotenuse and opposite sides. The same thing goes for secant and cosecant. Nope, cosine. Secant and cosine. Adjacent and hypotenuse switch. And then tangent and cotangent also switch their ratios. For the quiz and the test, you will need to know what these abbreviations represent. So that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And then you will need to remember the reciprocal functions. So these three are flipping those fractions. You might have learned in geometry a mnemonic to help you remember the 6 trig functions. And this was SOHCAHTOA. S stands for sine, O stands for opposite, C stands for cosine, A stands for adjacent, H stands for hypotenuse, T stands for tangent, O stands for opposite, A stands for adjacent. And again, I would just need to remember that the reciprocal ones are the ones that match up. Let me talk about how I remember these. Tangent and cotangent are both the only 2 abbreviations with T's, so that's how I remember they go together. Cosine and secant, they kind of look the same but spelled backwards, and they just change the middle letter. So I have COS and then SEC, flips. And then sine and cosecant are the 2 that are left over. So that's how I know that those 2 go together. So finally, before I get started on an actual problem with the notes, it wants me to recall that the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are lengths of the legs, so the opposite and adjacent sides, and c is always the length of the hypotenuse, which is the longest side, or if it's a trickier right triangle to tell, it's always right across from that right angle. So, number 1 wants me to use the triangle to find the exact values of the 6 trigonometric functions of theta. So what I want to do here is I only have 2 of my sides labeled with a side length. I want to find the length of my hypotenuse. I will be using the Pythagorean theorem to figure this out. So what I want to do here is I want to label A, B, and C. I said my hypotenuse is always my C, and it doesn't matter which sides are A and B. So then I'm going to plug into the Pythagorean theorem to find the length of C. So I'm going to have 3 squared plus 4 squared equals C squared. 3 squared will give me 9. 4 squared will give me 16, still equaling C squared. 9 plus 16 is 25. And then what I want to do here is I want to take the square root to figure out my value of C. Which is 5. So I'm going to write that over here. Sometimes when you're doing this, you will get radicals. If you get a radical, you want to first see if you can simplify it. Remember, we did that last semester, I think in chapter 1, where we were simplifying radicals. And if I can't simplify it nicely like I did here, I can leave it as a radical. So then what I want to do next is I want to figure out my trig functions. I'm going to start off with sine. Sine is always my opposite side over my hypotenuse. So what I'm going to do here is I'm going to label these with letters O, A, and H to represent opposite, adjacent, and hypotenuse. So this is my opposite because the angle I care about is right here. So it's not touching that angle. This is my adjacent side because it is touching the angle and it's not the hypotenuse. And then this one was labeled as the hypotenuse, so I'm going to have the H. So for sine, it's opposite over hypotenuse, so 4 over 5. Then I'm going to go ahead and find cosine, which is adjacent over hypotenuse, so 3 over 5. My tangent is opposite over adjacent, so my opposite side length is 4, my adjacent is 3. Then for the other 3 functions, the other 3 trig functions, which are commonly called reciprocal functions, I am going to take them and find the reciprocal of the 3 functions I just found. So cosecant matches up with sine. I just take this fraction and flip it. Or I could additionally find my hypotenuse over my opposite side, which will again give me 5/4. Then I have secant, which is the reciprocal of cosine, which will give me 5/3. Tangent, which reciprocal is cotangent. When I switch that, I get 3/4. So all 6 of these are part of my answer here. So what I would like you to do right now is I'm going to do number 2 a little bit differently because I want to make sure I go over, because there's a few things that are a little different in it. I want you to pause the video, work on number 2, and then once you think you have the answer, talk about it with your group mates like normal, and then play the video, and I will actually go ahead and work out number 2 for you guys. So number 2, oh good, my triangle's still on here. I, again, have 2 of my sides labeled, and I need to find my 3rd missing side length. In this one, I actually have my hypotenuse labeled. This is my C, and then it doesn't matter what I make A and B. So I'm just going to make those 2 like that. And then I want to go ahead and plug into my Pythagorean theorem. So this time my A is the letter I don't know. Plus 2 squared equals 4 squared. Then I want to go ahead and simplify. So 2 squared is 4. 4 squared is 16. I want to go ahead and subtract that 4 from both sides. I end up with a squared equals 12. Then I want to go ahead and take the square root of both sides. 12 is not a perfect square, but what I want to see is if I can simplify it further. I am going to use a factor tree for 12 and see if I can simplify that. So I'll do that up above. My factors of 12 are 2 and 6, 2 and 3. I have a pair of 2's. So what I can do is I can pull a, it's still going to equal A. I can pull a 2 out front, and then it's going to be square root of 3. Because I can't do anything with that 3. It's left alone on the inside. So then this is the length of this side right here, 2 square root of 3. Now I can go ahead and find my 6 trigonometric values. The angle I care about is theta, which is right here. So this is my opposite. This is the side length that touches it. And this is my hypotenuse because it is the longest side and it's across from that right angle. So first thing I want to do is I want to start off by finding my sine. Sine is always opposite over adjacent. Opposite over hypotenuse. So opposite side length is 2, hypotenuse is 4. I always want to simplify my fractions if I can. So this will give me 1/2 for sine. Then I want to go ahead and do the same thing for cosine. This one is my adjacent side over my hypotenuse. So I'm going to have 2 square root of 3 over 4. This one, the 2 and the 4 are both even, and I can simplify those. So that's just going to leave me with the square root of 3 over 2. Then I want to do the same thing for tangent. So tangent is the opposite over adjacent. So my opposite side length is 2. My adjacent is 2 square root of 3. So I will simplify this because I have a 2 on the top and bottom. Remember, I still need something on the top, so I'm going to have 1 as a placeholder. And square root of 3 on the bottom. Typically, when we are working with trig functions, we don't want to leave that radical on the bottom. So what I'm going to do is I am going to rationalize my denominator by taking this square root and multiplying both the numerator and the denominator by it. So this doesn't actually change the value of the fraction, but it will get rid of the radical from the bottom of the fraction. So when I do this, it will give me square root of 3 on the top. Square root of 3 times the square root of 3 is really the same thing as the square root of 9, because when I'm multiplying two radicals together, I can multiply their insides. The square root of 9 is 3. 3 helps if I write what I say. So my tangent here is the square root of 3 over 3. So I always want to make sure when I'm working with the 6 trig functions that I rationalize my denominators and I don't leave any radicals on the bottom. So then I want to go ahead and do the same thing that I was doing up above. I want to go find my reciprocal functions. Cosecant is where I flip the fraction. So 2 divided by 1, which is just 2. Secant is I'm going to flip this fraction, or I could flip this original fraction and simplify from there. But I'm going to take this one because it's already simplified, and all I have left to do is rationalize that denominator. So I'm going to multiply it by the square root of 3 over the square root of 3, which will give me 2 radical 3 on my numerator and regular 3 on the bottom. On tangent, nope, not tangent, cotangent, when I look at my tangent function to use the reciprocal of, I can use anything I wrote in blue to flip. So I could flip this original one that hasn't been simplified. I can flip the one that has been simplified but not rationalized, or I can use the rationalized one. If I use the rationalized one, this will put my radical back on the denominator. So I don't want to use that one, and I'm not going to use this one because it hasn't been simplified, so I just don't want to make more work for myself. So I'm actually going to pick this middle step right here, the 1 over the square root of 3, to rationalize. To use the reciprocal, because then that's going to give me the square root of 3 over 1, which will just nicely simplify to the square root of 3. Okay, so then moving on, number 3 wants me to use the equilateral triangle shown to find the exact values of sine of 60 degrees, cosine of 60 degrees, sine of 30, and cosine of 30. So over here, it's got my 2 angles labeled. This one's 60, this one's 30. And then my side lengths are also labeled. I'm going to start off with my 60s, and I'm going to do 60 in blue. So for my 60, this is going to be my hypotenuse. My opposite side is the one that's not touching the angle, and my adjacent is the one that is touching. So for sine of 60, I want to make sure I write the degree symbol, because if I forget that degree symbol, it automatically means it's written in radians. And when we're working in trig functions, radians and degrees mean 2 totally different things. So sine of 60 is opposite over hypotenuse. This is going to give me square root of 3 over 2. And I'm going to go do the same thing for cosine. So cosine is adjacent over hypotenuse. My adjacent side here is 1, and my hypotenuse is 2. Then I want to go ahead and do the same thing for my sine of 30 and my cosine of 30. So I'm going to do 30 degrees in red. So over here, I still have the same hypotenuse. That doesn't change no matter which angle I'm looking at. Opposite is now the 1. Adjacent is now the square root of 3 because that's touching. So for sine of 30, this will give me opposite over hypotenuse, which is 1 over 2. And sine of 60, not sine of 60, cosine of 30. We already did sine of 60. Cosine of 30 is adjacent over hypotenuse, which is square root of 3 over 2. So what I want you to notice here is that (60 degrees and 30 degrees both add up to 1. No, that's not what I wanted to say. I wanted to say, notice that the 60 degrees for sine and the cosine of 30 both gave me the same values. Same thing for cosine of 60 and the sine of 30. These also gave me the same values. Because what I did was I just changed the angle I was referring to, and that's why they should match up. So if I'm ever looking at all of the angles in a triangle and I'm finding all of my trig values, I should have repeated values. So the next thing I want to talk about is this table of common trigonometric values for 30, 45, and 60. I am going to fill out this chart. It is helpful to memorize it, and I will, as I'm filling it out, tell you how I remember it. So you always go in order of the angles, 30, 45, 60, and I have conveniently written these out as radian degrees as well. So in radians, that's pi sixths, pi fourths, pi thirds. And then I always go in the order that I solve them in, so sine, cosine, tangent. If I mess up these orders, it will mess up the fractions for the pattern I'm about to tell you. So for sine, what I always do is I always write 1, 2, and 3. And then all of these are always fractions divided by 2. And then I would go ahead and take the square root of all of my numerators. However, if I take the square root of 1, that is 1, so I don't need to write that one. But these two, I will. So before I go any further, I also want to talk about all of these are coming from my special right triangles that you learned back in geometry. So remember, we have the special right triangle, which is 30, 60, 90, which we kind of looked up at, back up at number 3. And then for the 45 triangle, let me back up a little bit more. The 30, 60, 90 triangle is a special pattern where your hypotenuse is double one of your side lengths, and then the other side length is half the hypotenuse times the square root of 3. Then for the 45, 45, 90 triangle, you have two congruent side lengths that are the legs, and then the hypotenuse is the leg value times the square root of 2. So that's where these values are derived from. Okay. Then for cosine, these all flip. So then it's going to go 3, 2, 1. Again, they are all divided by 2. And again, I want to square root all of them. I don't need to square root the 1 because square root of 1 is 1. To get tangent, I would divide sine by cosine. So if I went back to the front and I looked at my ratios, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. What I'm doing is, let me do this on a sticky note. So I'm just going to write these as letters. I have sine equals opposite over hypotenuse, cosine equals adjacent over hypotenuse. and then I have tangent equals opposite over adjacent. So what I can do is I am telling you now that tangent is equal to sine divided by cosine. So if I rewrote that, I really have opposite over hypotenuse being divided by adjacent divided by hypotenuse. Remember, when I have a fraction divided by a fraction, I can rewrite this as the first fraction multiplying by the reciprocal of the second, which I have an h on the top and bottom. So those hypotenuses cancel out, and I'm left with opposite over adjacent. So that is why I can divide sine and cosine to get my tangent values. So if I take a look at these two, and I take 1/2 and divide by the square root of 3, divided by 2, my 2's will cancel out, and I'll be left with 1 over the square root of 3, which I need to rationalize. Let's use green. And when I rationalize, will give me the square root of 3 over 3. For 45, square root of 2 over 2 divided by the square root of 2 over 2 will give me the same value. Is the same value, so anything divided by itself is 1. And then I have the square root of 3/2 divided by 1/2, where if I went to go do this one, my 2's cancel out, and I'm left with the square root of 3 over 1, which just gives me the square root of 3. Again, I recommend you memorize this because it makes things easier. And when we're working out trig problems, sometimes it will say to leave your answer as an exact value. When it says that, it wants it as a fraction if it can't simplify to a whole number, and as a radical. It wants no decimals. And moving forward in trig, it will either tell you to answer in exact or approximated. Approximated is when you use the calculator. So, speaking of calculators, this is what we're going to do in the last few problems. I am going to use my calculator here. It wants me to evaluate the following functions and to make sure to pay attention to the mode my calculator is in. So if I take a look, if I am using a newer calculator, it'll say some words at the top. It'll say normal, float, auto, real, radian, and MP. The word I care about right here is the one that's in the place of the radian. This function has a degree symbol, so I want this to be in degrees. On a newer calculator, I can easily see from looking right here at this main screen. On an older calculator, you can check from this step. So I'm going to press the mode button, which is right next to second. And then on mine, this is the third one down. It might be the fourth one on it, or it is the fourth one down. On an older one, it might be the third one down. So then I want to arrow over to the word degree, press enter, then go second mode to go back home, second mode to go back home. And then now, if I'm on a new calculator, it will say degree. On an old calculator, the word degree will just be flashing. So then I want to type this in. My 3 trig functions, calculators only have sine, cosine, and tangent, which is why it's important to remember the reciprocal functions and which ones they match up with. So you can use the 3 calculator buttons to evaluate the other ones. So this problem is sine, so I'm going to type in sine and then do 76.4. And then I will press enter. I didn't say on the notes, but the homework wants you to round to the nearest 10 thousandths. Round to 10 thousandths. So this is 4 decimal places. Okay. So if I take a look, 4 decimal places here is 0.91. Nope, I did not write what I said, and I didn't say what I saw. 0.971, and then, actually I shouldn't have written that one. The 4th number is a 9, but the 5th number after it is a 6. So the 6 is going to cause the 9 to round to a 10, Because it's rounding to a 10, I need to add 1 to that 1 I wrote on the paper. So it's going to be 0.9720. And whenever I ask to round to the nearest 10,000th place, I want 4 decimal places written on my paper, even though in this specific answer that 0 isn't important. Because this tells me that you looked at all 5 numbers after the decimal to decide when you needed to round, and that you're just not being lazy here. So that is the answer for number 4. Then for number 5, this one is cotangent of 1.5. So notice there is no degree symbol. So this is in radians. And then also, this is cotangent. So this is a reciprocal function. This is the reciprocal of tangent. The way I'm going to type this into the calculator is I'm going to do 1 divided by tangent 1.5. So, because it's in radians, I first want to make sure I go ahead and change my mode back to radians. So I'm going to press mode. Let me go back. Press mode. Arrow down to radians. Press enter. Second mode to go back home. Then I'm going to do 1 divided by. This is because it's cotangent, which is a reciprocal to tangent. And then I'm going to press my tangent button and type that 1.5. So this gives me 0.07 and then 0. The 9, the number right after it is a 1, so it is going to stay a 9. And this is my final answer here. So now I want you guys to take a few minutes or pause the video, take a few minutes, actually no pausing here, the video ends. Stop the video, take a few minutes to work on 6 and 7, compare with those around you, and then once you feel confident, go ahead and work on today's assignment.